Hello, and this is a short conclusion about next developments, what I'm doing here in my Tripscode project. And what it is about is a few things that I wish to record for later remembering. And one interesting thing is that I learned a new nuance about C language, and this one is a quite important one, and this is I talk about it first. And everywhere in tutorials, when we search Google or something online, then we get those examples for realloc function, and the example is everywhere where you look on the tutorials, and everybody explains that you just the realloc equals the newly reallocated array, but really this is not the way the serious programming should be done. And this is an easy mistake that everybody makes. And we can take an example how it should be done here. And the way it should be done is like this when we explore this variable here. This one is a morph map, and this is a local variable to this function. And here we see that how this is realloc is really executed, and this equals to the local variable, and the reallocing is executed on the really global or another type of variable that is not local to this function. And this way, the usual example is that we see this variable here in front also. There's the doubling of those variables. And this local variable then gets examined of the result type. If it equals null, then the reallocating for the memory allocation failed, and then we can step back with our counters and return negative results for this function. And if it succeeds, then we get this. Then we execute the assignation for those two variables. This inside variable in the function then gets this assignment here that we use the local variable. This way it's possible to step back from a failed function. And this is one interesting nuance that I learned here, and that is very misleading everywhere around the internet, really. And I have all my code is with this paradigm that we are reallocating to the this inside variable, but now I understand that this is not the case how we should program in C. And probably if we are serious about our code, then we should remake all the functions this way. Why it is important? Because if we make this assignment here in front, this reallocating assignment, and we find out that this equals null, then we lose the already present content for this variable. And when we return from the function, then we are with empty-handed, and we should exit immediately with the program. But if we step back, let's assume that the memory is full, we cannot run this program anymore, but then we come back from the function. Our button push was returned the negative results. Then we can save. This is saving possibility is the important one there. That's why it is very important paradigm for this reallogging. And but this video is about new attempts in this Tripscode, and I'm attempting to create those morph maps. And the morph mapping is a really important aspect for a 3D animation program and those 3D systems in general. And lately I implemented this timeline here, and several ways that one can animate animation. But the next thing for this freeware project should be probably morph maps. And then I start this morph map system here. Right now it's only first steps in the system as integrating the system into the program. And we see here that I tend to use the already examples or already present code for those new things, features that I add to the program. Then I take older code and take a look at it, how it works there. Then I can memory refreshment. I remember how I did it, and I take a good example of it, and this way I can develop further. And what is developing about? Here I created a test function here. When I press Alt-M, then I add a new morph map to this object. Here we read add new morph map to chickpoo's head and new morph to face. Let's assume that this face part is a selection of vertices that we wish to apply the morph maps. Then we see the list is like that. We get object. Under the object we see list of morph maps, and under those morph maps we see individual morphs that we model and animate later. And those morph maps are really relative offsets to the present geometry. They are not absolute morph maps, but rather offsets. I guess it's the right way. But it could be either way. Anyway, they are applied before the transformation. The base neutral pose gets first in the frame applied the morph, and then this newly morphed geometry then is transformed into a pose in the animation. This is the idea of it. And this way we could probably make several expressions here on for example, on the human face. And another type of morph is then the muscular animation, maybe. And this is dependent on the limbs poses, probably. And what sort of freedom is given for for the user in this program, then it depends. Then later in the development process, it reveals what is possible and what is meaningful and what is useful. And there are several ideas for the morph animation that when we get a rig, then probably we have a body and then we have clothes on. and we wish that the muscles don't penetrate the clothing, but those clothes are really a separate object. We wish to change for several clothing, and that's why this morph map is sort of applies at the same time for the body and for the muscles and for the clothing that is on the objects in the deformer. And this is one of the aspects maybe when when it comes to animation. And when integrating those new systems here, then we first run those really simple tests that should work. And those tests that were printed out here, then we see where those tests are. Okay, I close up this program right now. And it should work with several occasions when we delete an object and we wish to get rid of those morphs that apply to this object. Maybe we should have a possibility to import an object to replace the already morphed and rigged object with a new geometry that has same topology in it. And maybe this is also a feature that we wish to keep in mind when developing those systems. But those are complicated systems, and we wish to have those very basic simple things that adding, deleting, and those things in place. And this test here looks like this here in the main file. Here we see this when I pressed Alt-M, and then I get this this chunk of code here. This is like a test that is later not necessary, but when we add those underlying systems, then we wish to test very often and at every step possible that we can. And here we see that this new expression is added also to this new morph map. And nothing more. No vertices are specially selected, nothing. But only this basic allocation and those types of things. And when we delete the object, then we see here those functions are executed. Maybe search for free object. So this function here. This is an initializing functions file. And we see that when object is deleted, or the current scene is closed, or the program is closed, then those objects in the scene get freed. And this function here frees all the allocated stuff here. It's very long. And also subdivision levels get freed up. And sort of GL vertice arrays get freed up, and lots of things happen when deleting happens. And then we see here that I apply this free morph maps for into this function here in the end part of it. And these free morph maps, we're taking a look at it. Find the implementation, and then we see here that morph maps for the current object then are freed, and we see that those morph maps are scrolled. There are, as I explained, maybe it is a face morph, then it's a limb morph for arms and legs or whatsoever body morph. Possibilities are quite large. And that when we see here what is about this freeing, those morph maps are scrolled, and every single morph map is freed, and finally the object array for those morphs are also freed. And this C development environment is very good at this free function, because when you have tried to free something that was not allocated with malloc or calloc or realloc, then this sentence pops up an error, and this one is a very sensitive one. And this one is a testing place where you see really that your code is fluent, that you are trying to free only things that you have allocated. And to be certain that this one doesn't fail, then it is good to allocate zero length arrays. Just call malloc or calloc with 0 in it, and then you get this pointer in, and when it comes to the freeing, then it doesn't fail. This is another important thing in C language. And let's take a look what this inside function free morph map does. And this is here right above, and we see that the morph map name is freed. This is also allocated, and those verts and sort of things that the initializing function takes care of, and finally this morph map is freed. But beforehand it scrolls those individual morphs that are those expressions for the morph map that are inside for this vertice selection applied. And those morph maps, those also need to be freed, and this is a special function for them also. And for finding this implementation here right above. And here it has also a name and has this position lists. Position lists default to the vertice selection length. When those every vertex is not displaced, this doesn't matter. It still operates on this discrete selection. And finally this morph is also freed. So they are freed, but one thing to notice about the programming tradition here in this program is that we communicate with those arrays through pointers, and this is a convenient way that we can create this type of pointer here in the functions that is descriptive to this variable that we're dealing with. And this way we get this assignment. First we declare this morph pointer, and then we assign this pointer, and we are going to operate on this new data. And then this way it is more convenient that we can read it, what's about or what is going on. And to get those pointers to work, then we need really those arrays to be the arrays of pointers. And what it looks like in C language is like this. We see that 2 stars precede the variable name, and this means really an array of pointers. And with the arrays of pointers, this is another aspect that we can do, is that we can create an global array that sort of is a container for those pointers. That also is an array of pointers, but it is a prefixed length, and this one looks like this here. And this is a convenient way to program when we add those morph maps, for instance. Then we get the function add new morph map. Here we see it. Also a name is submitted to this function, and then we see this global interaction here, morph maps. In square brackets morph map index. This keeps the counting for those morph maps equals the allocated map m. And this array doesn't get modified when deleting objects. And this is maybe a little bit of problematic when those morph maps are associated with objects. Then we shouldn't move those global arrays, because there are another objects later, and they utilize also those pointers there, and this handling for those global arrays then is at later stage in the development, when we wish to use those global arrays in some way. Maybe there are some possibilities to use it, but other ways, when we don't understand the use of those global arrays, then we don't touch them. Then we just keep the counting going, and they are just really array of pointers. Then they are pre-allocated already. Here we see that they are sort of static type of arrays. And when the program starts up, then those global arrays, they don't get any mallocs or callocs called, but they get those finite length for the program lifetime. And this way can we also have a little bit control of what we assume that our real numbers are for those morph maps or whatever type of objects we create here. And this control is, I think it is necessary, because we wish to control everything when we program. And what to say else here? Then of course we get adding those new things, then we need to get rid of them. We wish to be able to delete them, and when the system goes on and we sort out of various things that we can do it with, then we wish to save them and also load them. And the saving and loading, this is very important also to do, maybe even beforehand, before we implement the functionality and UI. And there are lots of works with this new feature. We say that we wish to have morph maps and whatever expressions, and really to get going with these first steps, we need to take great care at every line